Hello and happy April 1st. So, welcome to standard form versus factored form. We've talked about this a lot in, I guess, yesterday's lesson and a little bit here and there. So, let's get to it. All right. So, we talked about the area method. And you can do this one of two ways, both of which you know. One is the area method, and the second one is distributive property. So, I like the area method, and I do want you to take notes or pause it because when I'm done with one of these examples, there's just not enough room. So I'm going to erase it and then do the next example. All right, so let's start with the first one. So we have factored form, and remember, factors are pieces. It's like taking an expression and breaking it into smaller pieces. So I know that one of the factors is x minus 3 and the other is x minus 5. So if I make my square or rectangle this kind of shape, I know I'm going to have x minus 3 as one of my sides and x minus 5 as the other. It does not matter which one is on the top or which one is on the side. So I'm just going to do this so I can break it into smaller sections that I'm then going to multiply. Remember, factors multiply to give you the entire area, and the entire area would be your y value. All right, so x times x is x squared. X times negative 3 is negative 3x. Negative 5 times x gives me negative 5x, and negative 5 times negative 3 gives me a positive 15. All right, so now I'm just going to combine my like terms. I have negative 3x minus 5x, and actually, why don't I write all of that out just because we're learning it right now, right? So I have x squared minus 3x minus 5x plus 15. Oh, all right. So now I'm going to combine my like terms, which gives me x squared minus 8x plus 15. All right, so that's my standard form. Oops, what am I doing? All right, x squared minus 8x plus 15. Remember, these two expressions are equivalent. They're just in different forms, and they both would equal my y value. All right, so I want you to think, what is the connection between the negative 3 and negative 5 here, and the negative 8? And then what's the connection between the negative 3 and the negative 5 and the 15? All right, so just think about that. They'll ask you for a few noticings and wonderings throughout. Now I'm going to go on to the next one, so I'm going to erase this. All right, and what color should I choose? I think I will go with red. All right, so again, you guys know x times x is x squared. X times negative 5 is negative 5x. But I want to do that in the area method. So one side is x, right? I don't have anything with it, just plain old x. And then the other factor is x minus 5. X minus 5. So this one I'm just going to split, right? So I have a rectangle that looks like that. Now x times x gives me x squared, and x times negative 5 gives me negative 5x. So when I add up what's inside of the area box, I would get x squared minus 5x, which is exactly what I have here. All right, so now let's go on to the next one. Let me just put y equals. And this is not much harder. It's just coming at it from the other direction. And let's do this one in yellow, right? Okay, now this is in standard form. That means it's on the inside, right? So each of these in the factored form have been outside. All right, so now I'm going to have my box, and just like I've set up the other ones, I'm going to put x squared in the first box because I just have one of those. And then I'm going to put 5 here by itself. All right, so now I need to know what two factors of x, right? It's hard to talk and teach. I'm trying here. All right, so what would those two x values be in order to find the sides, right? So I want to know this side times that side. All right, so let's work backwards. So here I have x squared in this one rectangle, or I know it's x squared, so it's a square. And so what times what gives me x squared? I hope you said x times x. So x times x gives me x squared. I'm good. All right. Now, here I have a question mark. I don't know what that is, right? So x times something gives me something else I don't know, right? So let me try working with the 5 here. All right. So I know I need to have two terms that multiply to give me 5. And lucky for me, 5 is prime. Now, what does prime mean? It means it only has two factors, 1 and itself. So I know that one of these guys has to be 1, and 1 times 5 will give me this 5. All right, so now I've got to make sure that those numbers, the 1 and the 5, will give me x values that combine to a positive 6x. All right, so let me erase these question marks because we're about to fill those in. So here, 1 times x gives me 1x, and x times 5 gives me 5x. All right, now 1x plus 5x does indeed give me that 6x right there. All right, so my factored form here is x plus 1 and x plus 5. And again, what is the relationship between the 1 and 5 that would give you 5? And what's the relationship between the 1 and 5 that might give you 6? So think about what operations, what is connecting those guys. Alrighty, now the last one we're going to do in green. Again, I got myself some factored form, so I'm going to be outside of the area model. Okay, so one side is 2x plus 3, this whole parentheses. I don't care if you put this on the top like we did or on the side. I just care that they're together. All right, and then the other side will be x plus 6. And now we've just got to multiply away. X times 2x, 2x squared. X times 3, 3x. 6 times 2x, 12x. And 6 times 3 is 18. Now, notice I don't have any negatives in there. All right. If I don't have negatives, then that means it's a positive or a plus. So I only have one term that's an x squared term. So I'm going to write that 2x squared. Here I have 3x plus 12x. So 12x, 13, 14, 15. So I'm adding 3 to that 12x. So plus 15x. And then I just have a constant of 18. All right. And again, you can put either of these. You can put the factored form or the standard form in your calculator, and you will get exactly the same graph. All right, because they are identical or equivalent expressions. Okay, so these are asking you to rewrite it in standard form. So we just went over that. If you want, you could even fast forward this a little bit and see if you can get to the next question. All right, but let's go ahead and do it together. So here I've got x plus 5 times x plus 5. These are in factored form and they go outside, right? They are the side lengths. So x plus 5 and x plus 5. Now, even though I didn't draw it to look the same, right? Because I just didn't draw it perfectly, you can look to see x plus 5 is exactly the same expression as x plus 5. So this is a square, right? Whenever you have identical side lengths, the length and the width are the same, that is a square, what we would call a perfect square trinomial. All right? So let's see what's inside this thing. X times x, x times 5, 5 times x, and 5 times 5. All right, so I've got x squared plus 10x, right? I've got 5x plus another 5x plus 25. And again, these two are equal. They're just different forms. This is standard form, which means it is inside. All right. And again, these are called perfect square trinomials. All right. So let's look at the other one. How is this one different, guys? So I'm going to draw it. See if you can figure out how is that different. Let me see if I switch to yellow if that shows up more. All right. So I have x minus 5 and another x minus 5. So far, they are identical. This is another perfect square trinomial. All right. But wait a minute, they're not really identical to the last one. If you notice, I've got a negative 5 and a negative 5 here, right? So in your mind, or you could do it on your paper, try to figure out how is my answer going to be the same and how is it going to be different than the problem we just did on the left side. All right, so let's get going. X times x, x times negative 5, negative 5 times x, and negative 5 times negative 5. Remember, a negative times a negative is a positive 25. So let's write that in. X squared, and now I've got negative 5x minus 5x. So remember, if they're the same sign, you add those coefficients and keep their same sign of a negative. So that turns into a negative 10x. And if you notice, that's a little different than this positive 10x. All right. Now, the 25, that's the same, plus 25. So the only real difference was the sign in your middle term. All right. This is working backwards. So I have my standard form. Let me actually write this in black. Okay. So this is my standard form. And that means it goes inside. In. So I set up my box. And I know that the first term goes in the first box. And that would be x times x. All right, so without even knowing anything else, I can set up my factored form as having an x in the first parentheses and an x in the second parentheses. All right, they come from this, x times x. Now, I know that 36 will be the constant in the last box. What I don't know is how I'm going to get these two x terms. I know that there is going to be an x, right? I see it up here. X times something gives me an x term. And then here I have this x times something gives me an x term over here. Okay? But what are those numbers going to be? So the key to it is looking at the 36. Now, what are the factors? Remember, the outsides are factors, right? Factors, all right, of 36. So I got 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 wouldn't go into it, 6 times 6. And as soon as I see a repeat, I know I found all my factors. All right, so let's go back to what terms would go in here. Now, I know I would be adding them. You're combining your like terms, right? So I know I'm going to either add or subtract. Let me not just say add or subtract to give me 12. So let me look at these. 1 plus 36 is 37. And if I subtract them, I would get 35. So 37 or 35, right? If I subtract them versus if I add, neither of those give me 12. Here, 18 plus 2 gives me 20. And if I subtract the two, if I find their difference, I would get 16. Neither of those give me 12, right? I want the 12 that's right here. Now, 3 plus 12 gives me 15. And if I find the difference, that's a 9. So I'm getting kind of closer, but neither of them are 12. 9 plus 4 gives me 13. And the difference of 4 and 9 is 5. Again, neither of those are 15. Neither of those are 12, right? We're looking for this 12 here, that middle term. Okay, now 6 plus 6, look, is 12. And if I do 6 minus 6, that's 0. So ding, 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 ding. This right here is 12. And I want it to be a positive 12. So I know I'm going to have a positive 6 and another positive 6. Okay? So now I've got to test it out. So x times a positive 6 is a positive 6x. And here, this 6 down here times this x up here is another positive 6x. And 6x plus 6x, you got it, gives you 12x. So I'm going to put plus 6 and plus 6. So that is my factored form. All right. So think back to the last slide. The difference here is you have a minus 12x. So I want you to play around with that and see if you can get a factored form that will look almost identical to what we did in that first problem, that first example on the left, but there's gonna be a difference. So play around with it, tinker with it. It's a good question to ask if you email or come to office hours, but I think you'll get it. All right, last thing, Regents connection. So when the quantity of 2x minus 3 squared, right, is subtracted from 5x squared, the result is, and so the one thing I want you to note here is the is subtracted from. Remember, that's one of the phrases where you actually switch the order. So the 5x squared comes first, and you're subtracting 2x minus 3 squared from that. So I'm just going to rewrite it as 5x squared minus 2x minus 3 squared. Now, I know a lot of you guys are going to just want to do 5x squared minus 2x, maybe do like a little distributive here, right? Don't do that. Fight your urge, right? So the reason I can't do that is I've got to do the squared, the exponent, before I can distribute anything in those parentheses. So that begs a question. What is 2x minus 3 squared? So let me just work over here a little. 2x minus 3 squared is the same as saying 2x minus 3 times 2x minus 3. So now I can make my area model. I can say 2x minus 3 and 2x minus 3. Now 2x times 2x, 4x squared. 2x times negative 3, negative 6x. Negative 3 times 2x, negative 6x. And a negative 3 times another negative 3 would give me a positive 9. All right, so I'm going to write 5x squared minus, and instead of writing all of this, I'm going to replace it with the standard form. All right, so that means 4x squared, and then negative 6x minus 6x is negative 12x, and plus 9 is plus 9. I just squished that in there. All right, I'm going to erase this bottom part here. So if you need to copy it, make sure you give a good pause. All right. Okay, so now that I've gotten rid of the squared by changing this factored form to standard form, I can now distribute this negative. So negative times 4x squared, negative times negative 12x, and a negative times positive 9. All right, so let me just do that. So I start with 5x squared, and a negative times 4x squared would give me minus 4x squared. A negative times negative 12x would give me a positive 12x. And negative times a positive 9 would give me a negative 9. Now, before I do it, can you figure out where the like terms are? All right, if you said right here, you are correct. So I'm going to subtract the coefficients because the x squared is the same. So that allows me to subtract my like terms. So 5x squared minus 4x squared gives me 1x squared. And then I'm just going to rewrite the other terms. Oops, did I put minus 9? That's supposed to be a plus 9. All right, so plus 9. All right, and that 1 can be an invisible one, so I can just erase it like that. All right, so my answer choice is option 4. I got x squared plus 12x plus 9. And that is where we are going to leave it. So you guys know what to do with your questions, concerns, and comments. I will see you in office hours. Bye-bye.